sector of a circle, and this is the introduction. To give you a definition, a sector is a part of the circle, and this part is bounded by a central angle and two radii that intercept the arc of the circle. If you want a visual, think of a sector as a piece of a pizza or a piece of a pie. So here's your first example, but when you look at that circle, first thing that should pop in your head when you see the circle are two formulas from geometry. Pi r squared, which is the area of the circle, and that's the one we're going to use, and the other one, 2 pi I, the circumference of a circle, which you may have seen already when you were trying to find the arc of a circle. So now, I'm going to do this two different ways. First of all, you'll see in your relationship here, you're doing a part to whole. So you got theta over the full circle, and then you're going to multiply it. You want to find the area of this piece right here, so you're going to multiply it by pi r squared. Now, instead of 2 pi, I could have written 360 degrees. But I want you to get used to converting these degrees into radians. And you've seen that in a prior video. So first thing I need to do is I need to use my conversion factor. I've got the 150 degrees and I want to convert that to radians. So my conversion factor is pi over 180 degrees. Now, let me cancel out. I can knock out the degrees. I can cancel out the n zeros, which means I'm dividing by 10. And the common factor is 3. So what I'm left with is 5 pi over 6. So now I'm ready to plug that in. So what I have is I have 5 pi over 6, that's now theta, over 2 pi times pi r squared. Looking at this here, I can look at that as a complex fraction. So what I can do is inverse reciprocal flip it, and then when I look what else I have, I know my radius is 10, so instead of that I've got 100. Now let me rewrite this because it looks a little bit messy. So I've got 5 pi over 6 times 1 over 2 pi, and then times pi times 100. So let me cancel out anything that I can get rid of. I can get rid of these pi's right away. I can look at this. 6 times 2 is 12. Okay, 12 and 100, my common factor is 4. So I can say 4 into 12, 3. 4 into 100 is 25. Now I multiply top, top, bottom, bottom. So 5 times 25 is 125 pi. And on the bottom, I'm left with 3. And let me do my label. And because I'm doing an area, it's got to be squared. And that would be my answer. Now let me show you the same problem, but just a little quicker, a little bit easier. Before I even start, let me simplify this piece right here. One thing I can do right away is I can cancel out my pi's. So now when I put this together, what I've got is I've got theta r squared over 2. And I can use this formula instead of this one, just by simplifying it. So now, theta, remember what theta was? Theta was 5 pi over 6. But you know what? I don't like seeing that 2 in the denominator, so I'm going to rewrite that as 1 over 2. And then the only other thing I have is I have my radius, and I got to square it. So my radius is 10. 10 squared is 100. If you want to put it over 1 to make it look neater, you can do that. So now, 2 times 6 is 12. Now I'm ready to do some canceling. So as I start to cancel, divide by 4. 4 into 12, 3. 4 into 100 is 25. Multiply my tops going across, I get 125 pi. And on the bottom, I got the 3. Keep my label, it's area, so square. And this way just looks a little quicker, but it just depends on you. Okay, sector of a circle, part 2 is next.